All right, this problem, as you maybe have read already, it says you are an engineer for a company and are asked to design an open-top box to hold your product. Using an 11-inch by 17-inch piece of cardboard, find the dimensions of the box with the largest volume. So we're going to go from, I told you we're going to do applications this chapter. In the beginning of the chapter, we haven't done many applications. We haven't done hardly any. But we're going to work into that gradually as we get through the chapter here, chapter 4. So here's my 11 by 17-inch piece of cardboard, right here. Okay. So you're an engineer, and you're supposed to try to somehow. How are you going to take this material and turn it into a box? And you want that box to hold as much stuff, product, whatever it is, as possible. All right. So you want it to have the largest volume possible. So the way I would approach this problem is you're probably going to have to cut out corners. You're going to have to cut out corners here, like this, and then fold up the sides to create your open top box. Okay? So that's what I'm picturing. So you cut out a corner here, cut this part off right here. Same thing here, you cut out this corner, and this corner, and this corner. Well, how much do you cut out? Well, that's going to determine the height of your box, because if you cut out this much, cut out, like this happens to be 3 inches is what I cut off when I made this morning. If you cut out 3 inches and you fold that up, that's going to make the height on your box 3 inches tall. So that's kind of the question, is how much do I cut out? Because that's going to create the height, which is going to affect the width and the length on the bottom. Okay? So since that's what we don't know, let's call that x. So x is we're going to cut out an x by x squared of each corner. So if this was 17 inches across, and I cut off x here, and I cut off x here, what would be an expression for this part right here? Was 17, take off x, what's this? 17 minus 2x. And if this was 11, okay, and I cut off x here and I cut off x here, what would be this dimension right here? 11 minus 2x. Yep. So if you fold it up, let me write that out, I guess. So this was 17 all the way across. From here to here would be 17 minus 2x. From here to here would be 11 minus 2x. What's the most you could cut off? What's the biggest x could possibly be?
8.5. No, not really.
Bigger. It could be bigger than 3. Okay, if you cut off 3.5.
I think 8.5.
Oh, 8.5.
That'd be cutting off the whole thing.
Okay. Could you cut off 8.5? You're on the right track. Could you cut off 8.5 here and here?
Oh, 5.5.
If you cut off 5.5 here, if I cut off 5.5 inches here and 5.5 here, this whole flap would be missing, wouldn't it? See, certainly, and then you just have a flat. What you'd have left would just be basically, it would look something like this. Okay, you would have nothing to fold up. You'd have you not only have an open top box, you'd have an open end box. The box would look something like that. Okay, so you're on the right track, Troy. If you take half of 11, 11's your shortest dimension. The most you could possibly cut off would be 5.5 and 5.5. Okay, even then you wouldn't have much of a box. Everything would fall right out of your box. But so we're going to have to cut off somewhere between our domain, somewhere between 0 inches. Right? If you cut off nothing, you'd have a flat piece of paper. If you cut off nothing, this would be your box right here. That's not going to hold much. Okay. So, and it has to be less than 5.5 inches. So that's the domain of our function. So here's what we have. We cut all this off. We fold it. We end up with this box right here. One dimension is 17 minus 2x. The other dimension is 11 minus 2x. And we have a height of x. Okay? Now we're trying to maximize the volume of the box. That's your job. Find the largest volume. Make a box the largest volume possible. So how would you find the volume of this box? What would you do with 3 dimensions? Multiply them. You take the height, which is x, times the width, 11 minus 2x, times the length, 17 minus 2x. And let's go ahead and FOIL out 11 times 17. Anyone know what that is? 187, I think. Double check my math for me. 11 times negative 2x is minus 22x. 2x times 17 is minus 34x. Negative 2x times negative 2x is plus 4x squared. Combine the middle terms. Minus 22 and minus 34 is minus 56x. Someone check to see if that's right. Is 11 times 17 187? Okay. Just a quick note on mental math. The way I did it, maybe some of you guys do the same thing, is 10 times 17 is 170. So 11 times 17 would just be one more 17. So 170 plus 17 is 187. So that's a way you can try to do things in your head. Now I'm going to multiply through by x. So volume equals 187x minus 56x squared plus 4x cubed. So go ahead.
When I took my visit to Dubuque, there's this professor, and he was talking about, like, he was bragging, saying he could do all this mental math, and he was doing stuff times 11. He says if you just do, like, if you're taking something times 11, you add 1 and 7 and put that number in between, like, so it's 187.
Yeah, I didn't know that trick. That's a good one. So he's saying that 1 plus 7 is 8, so just put an 8 between here and you get 187. Yeah, interesting. All right, let's move on now to figuring out the volume. So here's the volume. Now, when's the volume going to reach a maximum? Well, it's an x cubed graph. So x cubed graphs normally go like this, don't they? Okay? So there's probably going to be a maximum somewhere, and there's probably going to be a minimum somewhere. So what would the derivative equal at both the maximum and the minimum here? 0. The derivative or slope is going to be 0. So let's do the derivative and figure out where that's 0. So v prime equals 187 minus 2 times 56 is 112x plus 12x squared. Like that. Okay? Now let's figure out where that's equal to 0. Now to figure out where that's equal to 0, what are some ways I could do that?
Factor.
Okay, factor. And I don't know if that's factorable or not. I'm thinking 187 is not divisible by, it'd be nice if I could divide everything by 12. But I think factoring might be a little bit difficult, but that would be the first thing you'd probably try. Or maybe not the first thing, but something you could try. What are some other ways to solve that equation? Quadratic formula. It's up there on there's the formulas up there on the wall, or you have it on your calculator. Let's just do it on the calculator. So let's use quad formula here. My A value would be 12. My B value would be negative 112. My C value would be 187. Someone type that in for me. Quad formula, you push program, then you go to, it's called quad-equad, I think, on most of yours. It should give you 2 answers.
2.1778.
Okay.
And 7.1555.
These are both the inches. So they're saying to get the maximum volume, you either cut off 2.1778 inches off each corner, or you cut off 7.11555 inches. Which one's the right answer? Yeah, you can't cut off 7 inches. It's only 11 inches wide. How could you cut off 7 inches here and here? That's impossible. This second answer doesn't make any sense with our situation. So this is how much we should cut out of each corner to get the maximum volume. So that's our height. Our height is x equals 2.1778. How about if I wanted to get my length and my width? Yeah, my length is 11 minus 2x. So you just take 11 minus 2 times 2.1778.
12.6444.
12.644 inches. height,